Um, Hello, this is Marcus Lee. I'm going to be doing the Wylock 7th grade mathematics lesson 20 worksheet. I have all 4 pages of the worksheet um, uploaded to this whiteboard app that I'll be using to go through the problems and walk through the steps. So, beginning with question number 1, the directions are to multiply the polynomial. We have x to the 7th power times the quantity x plus 5 inside the parentheses. So here we have to distribute, which is multiplying the number on the outside, which is x to the 7th, times both of these numbers on the inside. So first, when we do x to the 7th power times x, we could assume that there's a 1 power here, and we want to add these two numbers together when we're multiplying the exponents, so we get x to the 8th power, and then x to the 7th times 5, we just distribute normally, so we just put a 5 in front, and we keep the exponent. So we have x to the 8th power plus 5x to the 7th power. Number 2, I will rewrite so it's easier to see visually. We have y squared times the quantity y to the 6th minus 6y to the 3rd. So again, we want to distribute, so y squared times y to the 6th is, when we add these two numbers together, we get y to the 8th minus, and then multiply y squared minus 6y to the 3rd. So we keep this 6, and we get y to the 5th power. Okay, moving on, we have factoring. So this doesn't factoring methods change based on the power and also this leading coefficient of x, but today we'll just be working with leading coefficients of 1 and quadratic equations, which is x squared. So number 1, it's asking us to factor x squared plus 11x plus 18. And with factoring, we want to find two numbers that will multiply to equal 18, but then when we add those two numbers, they equal 11. So it's a little hard to understand verbally, so I'll try to do a demonstration. So, like I said, we're trying to find two numbers that multiply that equal 18. So we could list out all the factors of 18. So we have 1 times 18 is equal to 18, 2 times 9, 3 times 6. And I believe that's all of them. So as we list out our factors of 18, we can now add them. So this will equal 19, this is equal to 11, and this is equal to 9. And this number in the middle is 11, so we want to select these right here. And we get x plus 2 and x plus 9. Simple. Alright, going on to number 2, running out of a little space. I'll move it over to this side. We have x squared plus 3x plus 2. So, like last problem, we could just list out our factors of 2. And we have 1 times 2, and that's it. And then, so, we just add these up, that equals 3. And then we could write both of our factors right here. X plus 1 and x plus 2. And that's our factored form. Okay. That's page 2 done. Moving on to page 3, we can do number 12. So, when we're factoring, when we're factoring and we have a quadratic or an exponent to the squared, we don't want it to equal a number on the right side. So what we can do is, instead, we can move this 24 to this side of the equation by subtracting it, and set the entire equation equal to 0. So what I did there was I subtracted both sides by 24. This becomes 0, and we get a minus 24 on this side. So this one's a little trickier, but we can do it. So we just list out our factors of negative 24 this time. And if you look at this middle number, our b value, it's a negative, which tells us that when we multiply our two numbers to get negative 24, we want the negative number to be bigger, because when we add the two numbers and the negative number is bigger, then the middle number will be negative. For example, if we list out our factors of negative 24, we get 1 times negative 24, 2 times negative 12, 3 times negative 8, 4 times negative 6. So now when we add these, you can see that all of these are negative numbers, which we're looking for, but the one that we're specifically looking for is negative 2, which come from the factors positive 4 and negative 6. So we have s plus 4 and s minus 6. So we factored the equation, but we're not exactly done. Because we have an equal sign and it's equal to 0, we're looking for specific solutions of s. So what we do is we set each factor equal to 0. For example, you have s plus 4 is equal to 0, and over here s minus 6 is equal to 0. And we just want to solve for s. So s, we can subtract 4 from both sides, so we get s equals negative 4. And when we solve for this one, we just add 6 on this side, so s equals positive 6. So our solutions are s equals negative 4 and s equals 6. Next example, we could do number 15 here. So this is a mix of distribution and factoring. So earlier I said we distribute by multiplying this outside number q by both of these inside numbers, q plus 19. So what we get out of this is q squared plus 19q equals negative 34. And then again, we don't want this to equal negative 34. Instead, we want it to equal to 0. So we can move this 34 to the other side by adding. So we get q squared plus 19q plus 34 is equal to 0. So now, as you get better, you won't necessarily need to list out these factors of your number, but we'll do it just to get the hang of things. So factors of 34, we get 1 and 34, 2 times 17, and I think that's it. Regardless, if we add these up, we get 35 and 19, and we're looking for 19 in the middle, so we get our factors are 2 and 17. So q plus 2 and q plus 17 is our factored form. Set that equal to 0. Now we set both of our factors equal to 0. Q plus 2 is equal to 0, and q plus 17 is equal to 0. And when all's said and done, we get q equals negative 2 and q equals negative 17. And those are our factors. That about concludes our lesson. Thank you for listening. I hope this was helpful.